Welcome back to the trials and tribulations of my 8-bit breadboard computer build. In my previous video, we finished Kit 2 with some minor issues, just needing to add some insulation to the LEDs and fix the subtraction on the ALU. But we're going to go ahead and move on to Kit 3, which consists of building the RAM and the program counter. So I'm just showing you guys what comes in the manual, and there is a little note about the 220 ohm resistors for the LEDs, as you see there in caution. Ben Eater doesn't use them, but he includes them just in case you do need them. So it's just up to you to figure out how to place them. And then there's a list of the components that are included in the kit, as well as schematics. So the first schematic that you'll see in the first build that we're going to start is the RAM. So here's the schematic for the RAM. And then the following schematic is for the memory address register, and then the program counter. And then I believe there are also the integrated circuit reference, where it goes over the chips that are in the that you're going to be using in the kit, and how they work and what their purpose are, and where the pins are. So that just kind of helps you break it down with the schematic if you're getting kind of lost in the videos that you're following on Ben Eater's channel. And then in the end, it just shows you the overall project on how he finished it and what it looks like. So in Kit 3, we start by building the RAM first. Here you can see my breadboard. I set up the easiest aspects, which are the power cables and the chips. So we have 4 chips in total that we start with. We have 2 RAM chips, the 74189, and 2 hex inverter chips, the 74LS04. And I am putting the RAM together following Ben Eater's YouTube videos. And just like my previous videos, I'll go ahead and just give you the step-by-step process that I take and talk about the issues that I encounter along the way. The next thing for me to do is just wire up everything correctly. That way data can flow nicely. So as I mentioned, the top 2 chips are the RAM chips, the 74189 chips, and they handle 16 bytes. Our breadboard uses 4-bit addresses, and as I mentioned, that's 16 bytes of RAM. So after applying a binary number to the 4 address inputs, data can be written or read to the memory. And Ben Eater mentions that the other side of the 74189 chip is inverted. So that's why we're using the 74LS04 chips to counter that inversion, because we just want the data to be identical to the input as the other side of the 74189 chip. I will continue the entire build and note my issues to be solved as I progress with this project. Some issues I had in the past as a novice is just, missing the pins, maybe just rewiring issues, not paying careful attention. As noted with my registers, I do have to add insulation to the LEDs, so I'll have to go back and do that. However, for the RAM, I'm just going to do it directly to these LEDs. And then the 220 ohm resistors, I do need them for my build. You might not, but if you do need them, you just have to redesign the breadboard a little bit, because Ben doesn't use them in any of the YouTube videos and they're not included in the manual photos. So as I mentioned, our breadboard computer uses 4-bit addresses, which is a total of 16 bytes of RAM, and this does limit the size and complexity of the programs that it can run. But other than that, I'm just going to keep going and just try to wire up everything as neatly as possible. So here I'm just taking a break to show what I've done so far with the RAM. Here we have the 20 ohm resistors, but as I mentioned, are not in the video or the picture. And then, as I mentioned earlier, I have to add these little pieces from the wires that I've cut to kind of give it some insulation. That way it doesn't mess with the LED lights, because I was having problems with that before. And then I've just color coded these cords here, the red ones, just showing that that's linking to the LEDs, just because it wouldn't look pleasing to go ahead and put the light bulbs on the other side. So we use these cords here just to connect it and keep this alignment here. So yeah, just wanted to take a break and show my board right now, show the wires here connecting the RAM to the inverters. Just because of on the RAM on one side, a few of them are inverted, so we have to go ahead and undo that by adding the 2 inverters over here at the bottom, the 74LS04. So this is so far what I've done. and we're just gonna keep on going. But like I said, here's the breakdown for the LED bulbs, which is really just the placement changing because of the resistors and adding those little wire bits to give some insulation. I don't know if I like the way the LED lights are looking, but for right now they're okay. All right, so here we have so far what I've done with the RAM. So the LEDs, we've added some insulation, as you can see here, which I'll have to go back to my register and do. And we went ahead and put in the 2020 ohm resistors. And then here I just did these in red to show, okay, this is connecting to the LEDs here just to keep the display. And then for these two chips, they have a chip select on, I believe, pin 2. So we went ahead and just put them at low. That way they're always enabled. So this is what we have so far. You can take a look nicely. I might rearrange the LEDs to make them just look a little bit better, but for right now we just want to get this to work. So the next thing for us to do is to go ahead and add this chip here. And if you are building this, then it is the 74LS245 8-bit chip that we use for the registers. And basically it's like a bus transceiver. So we can go ahead and put what we have on the LED, load it onto the bus, and, you know, just mess with that data and see what we can do. So we're just going to go ahead and add that in here. Just gonna give it some space. We'll do it here. There we go. So we can go ahead and add that in with a little bit of manipulation. There we go. So now we'll go ahead and hook it up. And I did it this way because, as you can see, I'm using these parts to get our 2020 ohms linked to these LEDs. That way we can just kind of limit the current and not kind of blow these LEDs out. So just want to make sure that this is placed nicely and not going to go ahead and mess with what's going on here and vice versa. One thing to note about the 74LS245 chip, or the bus transceiver chip for bus transfers, is that we're only using it in one direction. So I just connected pin 1, as you can see here. I've connected pin 1 to high. That way we know what that we'll be using this direction. So the following step is to definitely connect the outputs, and we'll be connecting the outputs from pin 2 all the way to pin 9 to match our LEDs. That way we can just transfer whatever is going to be here to here, and then it will just go onto our bus that we were using previously for just testing the components of our computer until we have our centralized bus later on. So here you can see I've went ahead and connected all of the outputs that are inverted to the bus. So as you can see, I did it in red to kind of just make that distinction that, hey, these are the LEDs being connected to the bus transceiver. So here you go. Like sometimes I'm like, I don't know if they're too short, if they're sticking well inside the breadboard, but this is just what it looks like. I know it kind of looks messy, but here you can see kind of the points where they're connected. Maybe it helps better in this direction to kind of see a little bit better, but there we go. So we're gonna start just pretty much linking the address lines of these two chips together. So here's the final build of my RAM. I just wanted to go through a quick walkthrough before we begin testing it. So here we have the 8 data lines in green, then we have our 4 address lines in yellow, we have the random access memory here, we have our inverters here, and then we have the bus transceiver that we've seen in previous videos and previous builds when we want to go ahead and display data onto the bus, which we will do versus having the bus translate information here. And here we have enable. So I just wanted to take a close-up of my RAM construction. We will go ahead and test test the RAM in the next video. As mentioned, we've added these 220 ohm resistors, which are not in any of the YouTube videos or in the manual photos, and it does cause the need to redesign the placement of the LEDs. And they also have little pants that you can see here, or wiring that was stripped to provide insulation because of the previous issues that we've seen with the ALU, with my LEDs interfering with one another. But so far, here is my RAM. Here is how I place the LEDs. It's possible I'll change it in the future, but hopefully this can help others who also need those resistors and a little bit of guidance on how to place them. Thank you so much for watching, and until next time.